Hello and welcome to lesson 5.8 triangle area by trigonometry. Okay, so we're talking about triangle area by trigonometry, right? Okay, so ready? Uh, this chart tells us the total area of a few states in the US. It also shows the total land area, total land. Uh, that is less because part of the total area is underwater, right? So there's some stuff that is underwater. Um, use the information to calculate the percent of the state that is underwater. This is my total area of the state. So my land area is this, right? So my percent of area underwater is going to be 1 minus what is land, right? Percent land. So in this case, we're going to do 1 minus 53,625 over my total. Okay, so we're going to require to use a calculator for these calculations. So 1 minus parentheses 53,625 dividing it by 65,058. Enter and multiply this. They want percent, so multiply it by 100. So I get that's 18.45. So we can do 18.45%. Okay. Now, same thing for the next one. We're going to do 1 minus 55,519 over 57,914, which is equal to, and multiply it by 100, right? So 1 minus 55,519 all over 57,914. Multiply this by 100. Hope I don't know if that's going to work out. No, we see. Yeah. So uh, parentheses are important here. So if I can do this and then put parentheses there, there we go. We get a 4.13%. Well, equals to, well, and then I'm going to multiply it by 100. So we'll say that this is times 100 is equal to 4.14%. We'll just use two decimal places, okay? Next, same concept. So 1 minus 121,298 all over my total, okay, times 100 is equal to, so again, parentheses are important. 1 minus parentheses 121,298, dividing this by 121, 590, close the parentheses, times 100. This is really small, right? So this is a 0.24 percent. Cool. Again, I hope this is kind of making sense. So I'm essentially taking, if the land area over the total area gives me the land area, then the difference, right? The complement, as one might say, is the area underwater, right? So this is 1 minus 48,618 over 53,819 times 100 equals, what is you doing there? 1 minus 48,618, dividing this by 53,819 times 100. This is 9.66%. 9.66%. And then last but not least, 1 minus the same thing, the area percent, so 54,158 over 65,496 times 100. Okay, so this is all equal to, why do I keep saying a log there? 1 minus 54,158, dividing this by 65,496 times 100. So I get that 17.31%. Cool. Okay. I think that's all for a calculator. So these are supposed to be our final percent of area underwater. Okay. Let's do number two. Use the data in the chart to solve the problems. Perfect. We have the data in the charts. A dry climate is very beneficial for people with arthritis and osteoporosis. If you have these elements, which state in the list would be best for your health? So they want a very dry climate. So if you want a dry climate, that means you want to be you want to have a very what? An area underwater that is very small, right? Because that means that you're not as human. That's kind of thing of what they want us to think about, which is a pretty big jump. But so that case is New Mexico. Okay, so this is would be New Mexico, since only 0.24% of the area is underwater. Okay. If you want to live near water, which state would be the best choice? So again, living near water, uh, look at the percent of area that is underwater, and we see that Florida right there, right? So Florida, um, since 18.45% of the area is underwater. Of the area is underwater. Okay. Can you think of a different reason for your answer in number three besides the percent of area underwater? I was going to say this earlier, but it should be, well, I really don't understand why this is a question here. But we know that Florida is essentially surrounded by water, right? That Florida is surrounded by water. Okay, great, cool. Number five. Okay, so they want us to find the area. So find the area of triangle ABC in terms of sine of A. Okay, so I want you to understand why these are like this, right? So this is an angle, these are angles. So ABC are angles. ABC, excuse me, are angles, okay? And then the lowercase, so ABC are side lengths. How do you spell lengths? Oh my goodness, I always struggle with spelling that word. Is it TH? Is it, I don't even know. You see I'm spelling it wrong. TH, lengths are side lengths, right? Okay. So again, the area of a triangle. So then the area of a triangle is equal to 1/2 times my base times my height. Okay. So we can say that this is my base. So this is my base. Okay. And then what's my height? So my height, I can draw it right here. Okay, so we have, this is my height. Height, I wish this was better. Oh my goodness, just pretend that it's perfect, a height, okay? We'll call this H, height, okay? And then right here, we should know that this makes a right angle, right? It's perpendicular, so it hits it right there. Okay, cool. So then how does that help us? So we have that area is equal to 1/2 times my base, which is just B, times my height, okay? But I want it in terms of sine of A. So this is A right here. This is A. This is angle A. So let's think about the sine of that. So sine of A is equal to opposite. So that opposite is H over my hypotenuse. What's my hypotenuse? C, right? This is the right triangle here. So this is C, hypotenuse. So then I know that this is H here. And I have this in terms of sine of A. So how do I solve for H now? I multiply it by C on both sides, okay? So I'm left that H is equal to C times sine of A. So then my area of triangle ABC is equal to 1/2 base times C sine of A. And I am able to just kind of maybe clean this up a bit. B times C times sine of A all over 2. Okay? That 2 looks horrible. Okay, cool. Awesome. Let's jump into question 6 through 10. This is part of the set problems, okay? Set. So find the area of the triangle having the indicated sides and angles. Okay, so again, what are we talking about here, right? So if I give you a triangle, so let's kind of do this. Let's draw this triangle here. Let's try my best to draw a triangle. Okay, this is a triangle. It's not a right triangle, right? Because it doesn't tell us that. So let's label. I'm going to label this as A, B, C. Those are my angles, right? And then this is going to be angle C right here. C is 84.5. Okay, what is A? 32. So that goes here. This is equal to A, right? It's the opposite. And then opposite of the angle B, B here is 40. Okay, so I want to make sure that I find the area of this triangle. So then the area formula, when I have a triangle here with two side lengths and an included angle, okay? An included angle. So my area is equal to 1/2 times A times B times sine of C, okay? So this is kind of where we come from part 5, right? So we wanted to find this angle. We have that it's 1/2 times B times C times sine of A, okay? So in this case, we want to think about what we have. So we know that my area is 1/2 my side length. What am I given? This is 32. This is 40 times sine. What's my angle that is given to me? My included angle is 84.5. And let's make sure this is degrees. Okay? So this should be my entire thing that I'm typing in. Okay? And again, this kind of goes from what we did over here. Okay? Let's type this into our handy dandy calculators. Again, it's important that I am working in degrees. So mode, go to radians, go to degrees. Okay, this is all in degrees. The angle that is given to me, it's in degrees. If you're not in degrees, you're going to get something completely wrong. Okay, so 32 times 40 times sine of 84.5. What am I missing? Divided by 2. Okay, right. So that I get it's 637. Holy moly. Um, so the area of this triangle is is 637. Let's do 2 decimals, 0.05 units squared. Okay. Okay. Let's keep on chugging along. So I want to again draw a triangle. You need to draw photos for graphs of it all. Not graphs. You need to draw triangles for all of these, right? I recommend you draw triangles. You need to do it. Okay, it's a must. Okay, so this is going to be A, this is B, and C. And let's label what we have. So now we have this angle right here. So now we have this is 29 degrees. And then B is 49. So we have the B is 49. And we have C is 50. So C is 50. Okay? So same thing. My area formula here is going to be 1/2 times, what am I given? I'm given one of these angles, so one of these sides, 49, times 50, and my included angle in the middle is sine of 29 degrees. Okay, so again, what I'm doing there is that I'm gonna go ahead and work on my calculator, right? So I get this is 49 times 50 times sine 29, all of this divided by 2. Okay, so I get that this is 593 point and 89 hundredths units squared. Okay, cool. I'm gonna keep this here again for number 8. Again, another triangle, and I'm gonna become an expert at drawing triangles. If only my perfect. Okay, so again, labeled as A, B, C, and again, you can label this anywhere you like. I can change this up. I can call this A, I can call this B, I can call this C. But as long as you label it intentionally. So this B is going to be this angle right here. This is 72.5 degrees. A is opposite of my angle, so A is 105, and then C is here 64, right? So I have two side lengths and an included angle. So again, my area for that is going to be 1/2 105 times 64 times sine of 72.5. Okay, I'm going to type all that in. 105 times 64 times sine of 72.5. Make sure you're in degrees. Dividing this by 2. Okay, so I get 3,000. So my area here is equal to 3,204 and 49 hundredths units squared. Okay, it's important that when we talk about area, you put your units. In this case, they don't tell us what the units are, so we just write units squared. Okay, it is very important that you do write this, and the concept of squared is important because area is squared. Okay, we were talking about volume, it would be units cubed. Okay. Let's talk about number 9. Number 9. So again, another triangle, right? These are all triangles. I'm gonna label this differently. Let's call this A, let's call this B, let's call this C. What I want you to get at is that I can label this any way I like. Anywhere your heart desires, you can label it like that, okay? As long as you label these appropriately. So this is 31 degrees, right? A is 15, so A right here is opposite of the angle, 15. And then B is opposite of this angle, so then B is 14. And let's do it. So A is 1/2 times 15 times 14 times sine of the included angle. So this is 31 degrees. Okay, so then we have this is a 15 times 14 times sine of 31 divided by 2. Okay, I'm also going to do it differently. I'm going to do 1/2 times 15 times 14 times sine of 31, and I'm going to get the exact same answer, right? So the way you type it in is entirely up to you. So this is 54 point, let's call this 0.8 units squared. Okay. And then number 10, last one of these problems. Let's go. Let's change it up. Let's use, oh my goodness, why doesn't it do it for me? It's not what I want. Okay, not a right triangle either. Oh my goodness. Okay, this just hates me, right? This hates me. Okay, cool. This is A, this is B, this is C. We're going back to our roots. So here again, I'm labeling this correctly as 42 degrees. B is 25, opposite of angle B. And then C, side length is 12, okay? So again, I have an included angle in between two sides. So my area will be equal to 1/2 times 12 times 25 times sine of 42, okay? So my area there is all equal to 12 times 25 times sine of 42 divided by 2. So I get 100.37 units squared. Okay. Now let's kind of just think about this on a bigger perspective, or like not a bigger perspective, right? But let's just kind of redo this um, paste, and let's do it without knowing the formula, right? So you could find this height again, right? You can find this height. So I know that area is 1/2 times my base times my height. So then this is kind of my height, right? So then my height, so then I can do sine of A is equal to height over my hypotenuse, 12, and I know that, oops, 12, and I know that height is equal to 12 times sine of A, which is sine of 42 degrees, right? So then A is equal to 1/2 times my base of 25 times 12 sine of 42 degrees, which is exactly what we have over here, right? So these and these are the exact same thing. I'm taking you through this process, but again, it all comes from this, and it comes from this formula, okay, right here. So you can think about it like that, okay? If both ways should kind of really make sense now, okay? This is kind of taking it the long approach. However, if you have an included angle, an angle that's included in between two sides, you can simply use the formula, okay? This formula right here. Okay, now we're in the go section. So indicate the values of, indicate whether you would use the law of sines or the law of cosines to solve the triangles, then solve for the missing values. Okay, so I'm gonna add a page here because I know these are gonna be a little bit messy. Let's go with 11. Okay, so then let's do a little bit of a, not a recap, but what am I doing? Oops, perfect. Okay, so again, when I have my law of sines is sine of A over A is equal to sine of B over B, which is equal to sine of C over C, right? That's my law of sines. And essentially what is happening there is that you need to have an angle, right? You need to have an angle. So law of cosines is going to be c squared is equal to a squared plus b squared minus 2 times a times b times cosine of c. Okay, so kind of just similar to what we talk about when we're talking about Pythagorean theorem. This is very similar, but let's call these a and b are your adjacent, right? So they're adjacent to the angle. Adjacent to the angle. And then C right here is my angle opposite of C, side length, okay? So honestly, you're able to kind of rearrange the law of cosines and work in any other way you want it to work at. Like for example, I can write this as a squared is equal to b squared plus c squared minus 2bc cosine of a, right? Essentially, it all comes from this, okay? And knowing this part. So I'm going to pick any side that I wanna, well, any angle I wanna find first. So just for the fun of it, and let's stick with this and let's find this angle C, okay? So I'm gonna find this. This is angle C right here, okay? So I have c squared. So that c squared is 118, right? So 118 squared is equal to a squared. So a can be, a is my adjacent. This is a, right? And this is b. So my a is 55.7 squared plus 110 squared. Now, what you have to keep in mind is that these are my adjacent. What did I do? These are my adjacent, right? These are adjacent to angle C, adjacent to the angle, okay? Minus 2 times A, so A was 55.7, times B, which is 110, times cosine of C. That's what you want to solve for. This is what I want to solve for, okay? So I have almost every single thing figured out. Now, all you need to do now is solve. Now you solve for C, big C, okay? You want to isolate this. So again, this goes back to solving, what we've been doing in the very beginning of the school year. So we have 118 squared, moving everything to one side, minus 55.7 squared, minus 110 squared, okay, is equal to negative 2 times 55.7 times 110 cosine of C. Okay, now all of this is a blob that is attached to this. This is a blob, okay, and this blob is getting multiplied. So how do I get rid of the blob and just have this by itself? I divide it, right? So I divide it on both sides. So divide this by negative 2, right? Sorry, I don't know what I'm saying. Divided on both sides, so I'm left with just cosine of C on one side. Okay, I hope that kind of makes sense. Let's rewrite this. So I'm left with this entire thing right here. Copy. This entire thing is equal to cosine of C. So all I am doing is that I am solving for cosine C here. Okay. I could not use the law of sines. I couldn't use law of sines here because I don't have any of the angles. So again, I would use law of cosines. Okay, law of cosines. And now you need to remember, how do I get rid of this cosine? Okay, how do I find this angle by itself? So I have to take my cosine inverse. So cosine inverse, and what I do to one side, I do to the other, right? So this goes away there. So I'm left with cosine inverse of this entire thing. This entire thing, cosine inverse, is equal to C. This is what I want. This is what I want, okay? So now it becomes a big chunk problem of chugging all this into my calculator, okay? Let's go. So cosine inverse, where is that? You have to click second and you go to the cosine button, okay? So cosine inverse, you have to be really careful with your parentheses here. So we have 118 squared minus 55.7 squared minus 110 squared. Dividing this by open parentheses, negative 2 times 55.7 times 110. Close those up. I get 84. 84.01. Look at that. So C is equal to 84.01 degrees. Okay, I want you to use 2 decimal places for the most part, just because it makes our answers more accurate. Okay, okay. So that was a lot, right? Essentially, what I did, I plugged in what I knew, and now I know that this is 84.01 degrees. Okay, now we have to find another one. What happened here? What is going on? What did I do here? What? What happened here? I'm sorry, I don't know what happened here. What did I do here? What? Okay. I have no idea what happened. Okay. This is my first angle. Now, I know this angle now. Now I have to do it again, right? I can pick an angle now. Which one do you want to do? You want to find this one or do you want to find this one? It doesn't really matter, right? Let's do A. So let's do cosine of A. That's what I'm trying to solve for now. So again, this right here would be A squared. So it's let me copy this and let's bring it down here. Make this smaller. Okay. So I want to find a cosine of A. So now I'm going to get that this is 55.7 squared is equal to my adjacent squared. So 110 squared plus 118 squared minus 2 times 110 times 118 times cosine of A. Okay? And now I just solve again, right? I'm solving for this. I want to isolate this out. So 0.7 squared minus 110 squared minus 118 squared equals to negative 2 times this times cosine of A. Now you want to divide this on both sides. So I'm left with okay, so now I'm left with this entire thing right here. Copy, paste. This is all equal to cosine of A. And again, to get rid of cosine of A, I do cosine inverse. It goes away. So now I'm left with cosine inverse of this entire, what's happening? Cosine inverse of this entire thing, okay? Is equal to A in degrees, okay? So let's just kind of plug all this in, plug it in, okay? So again, second cosine inverse, parentheses, 55.7 squared minus 110 squared minus 118 squared. Dividing this by open parentheses, negative 2 times 110 times 118. Close these parentheses up, and I'm left with 27.99 degrees. So we'll just call that 28 degrees. Equals to 28 degrees. Okay. So then right here we have that this is 28 degrees. Okay. Now to save us some time, a triangle adds up to how many degrees? 180, right? So triangle is 180 degrees. So if A degree, so angle A plus angle C plus angle B should equal to 180 degrees. So if angle A is 28 plus, let's just call this 84 degrees plus B degrees equals to 180. And I know that B is equal to 180 minus 28 minus 84. So angle B is equal to simply going to be 68 degrees. 68. Okay. So that was a lot of work, right? But we did it. So this was 60, oh my goodness, 68 degrees. Okay. So we did all the law of cosines, we did it twice, right? You have to repeat it twice to find two angles, and then once you find those two angles, we weren't so concerned about doing it again because a triangle adds up to 180 degrees, and there you go, right? Okay. Let's do number 12. So number 12. New screen. Okay. So Law of sines or law of cosines. So in this case, I have one side and two angles. So I have one side and two angles. You have to use law of sines. Law of sines. Okay? Because you don't know anything else. You don't know what this is. You don't know what this is. Okay? So find the measurement of angle B. So angle B right here is going to be equal to, let's talk about that. So 80 degrees. So 80 degrees and 60 degrees. So 80 degrees plus 60 degrees is equal to 140 degrees. So then the measurement of angle B is equal to 180 degrees minus 140 degrees. This is just 40 degrees, right? This is 40 degrees right here. Okay. So now my law of sines. I can't forget my law of sines. So my law of sines was right here, right? I talked about it right here. So I have sine of A, which is 80 degrees, all over 28 is equal to, which one do you want to find first? Doesn't really matter, right? This is C right here, and then this is B. So let's find B. So then I have that this is sine of 40 all over B. Okay? Um, Now, how do I solve for B? So I cross multiply, right? So I'm left with B times sine of 80 degrees is equal to 28 times sine of 40 degrees. And how do I get B by itself? I just divide, right? So B is equal to 28 sine of 40 degrees all over sine of 80 degrees. Okay? So I don't know how to do that off the top of my head, right? So that should be um, a big keyword or a big intuition that you need to use your calculator, okay? So parentheses, 28 sine of 40 degrees all over sine of 80 degrees right here. And I get that that's 18.28. Okay, so I know that B is 18.28. You can call this equal to AC. Okay, people will talk about this as AC. This is the length of AC, or I just called it B. Okay, and then let's talk about finding C. So I have A. I found AC. That's that one. And let's find AB, which is C. So again, I can set up a similar ratio, right? So I have sine of 80 uh, to 28 is equal to sine of 60, and let's call this is going to be AB now, right? Again, same concept. So AB sine of 80 degrees is equal to 28 sine of 60 degrees now. I just solve for this, right? So I divide both sides by sine of 80. So I'm left with AB is equal to 28 sine of 60 all over sine of 80 degrees. Okay, so again, going back to our calculator, let's do it. I'm left with 28. Again, let's make sure we're in degrees. I know we are, but let's double check. Mode, degrees, perfect. So I'm left with 28 times sine of 60, not 60, all over sine of 80. And we get 24.6. So 24.6 is 24.62. Let's call that 24.62 equals to 24.62, and I am supposed to write units. This is millimeters. And here we should also put millimeters, okay? Millimeters. Mm for millimeters. Okay, let's talk about 13 now. So 13 is right over here. Let's just see. Let's see. Yeah, I'll copy this somewhere else. copy, paste. Okay. So what do we have here? I have two side lengths. How do you spell lengths? Oh my goodness. Two side lengths. L-E um T-H. T-H-S. Okay. Two side lengths and one angle. Okay, so I have an angle that's included there. So um let's see. We can use law of cosines. Um yeah, let's use law of cosines for this particular one. I think that yeah, maybe we'll do it both ways. I think this one can be done both ways. But let's just do it right. So again, if I want to find I have this angle now, right? So okay, so I'm gonna be finding C right here. This is C. Okay, so in our law of cosines formula, we have this is going to be C squared is equal to A squared, right? So I have 14 squared plus, where is it? So law of cosines, let's go back to it, right? Plus B squared plus 19 squared minus 2 times 14 times 19 times cosine of C, which is 52 degrees here. So this one was pretty straightforward because I'm trying to find C squared, and then to find C, C is equal to the square root of this entire thing, right? Copy, paste. Okay, now let's go ahead and type this in. So I have a big square root of 14 squared plus 19 squared minus 2 times 14 times 19 times cosine of 52. Doesn't really matter. Okay, and I get that that is 15 .15 yards. So I get that C is equal to 15.15 yards. Yards. Let me just double check that I did that correctly because 15.15. Yep, perfect. Okay. So I now know this is 15.15. So now I need to find this angle right here. Let's use our law of cosines again. Okay. So I know that this is opposite. It's 14 squared is equal to my adjacent 1. So this is 15.15 squared plus my adjacent 2 squared. So 19 squared minus 2 times my adjacent 1 times my adjacent 2 times my cosine of b. Okay, again, I'm solving for b now. So I'm going to subtract to isolate it -2 times all this blah cosine of b. Okay, and I'm going to divide by the blah on both sides. What I do to one, I do to the other. It's one of those commandments I always say. Minus 19 squared all over -2 times 15.15 times 19 is equal to cosine of b. And again, I want to take cosine inverse to get rid of this, right? So I'm going to do cosine inverse of this entire blah. The blah is equal to angle B. Okay, And then let's just go ahead and type that in. So second cosine inverse, open parentheses, 14 squared minus 15.15 squared, minus 19 squared, close parentheses, dividing it by, open parentheses, -2 times 15.15 times 19, close parentheses, and I get that that is equal to 46.74 degrees. 46.7. So now I get that B is equal to 46.7. This is measurement of angle B. Okay. If you said 47, that would have been fine. I am just trying, if you would have said this was 15, that would have also been fine. I'm just saying that these are more precise or exact answers, and you should feel comfortable working with at least 2 decimals, right, and carrying them over just to be more exact with your answers. Again, no penalty. We would have said this was 15, so that would have been totally fine. And if it's easier for you to use those numbers, then go ahead. We have a calculator, right? I think it's fine either way. And then last but not least, the measurement of angle A is equal to 180 degrees minus the measurement of angle B minus the measurement of angle C, right? So measurement of angle A is 180 degrees minus 46.7 minus 52 degrees. So measurement of angle A, again, let's do it in our calculator that we know and love. 180 minus 46.7 minus 52 degrees. It's approximately 81.3 degrees, or just 81 if you were being less conservative with your answers. Oh my goodness. Perfect. Okay. I don't really want to go over how you would do this with law of sines. I want to try it just so you can see it. And maybe it would work because that's not what so if I have sine of 52 degrees all over, so sine of 52 degrees all over C, which I don't know, equals to, now you see you couldn't have done law of sines because you would have two different unknowns, right? So like if I have sine of this angle right here, so 52, that pairs up with the opposite, but if I didn't know what C was, it would have to be C, and it's equal to sine of B to 14, but I don't know, I would have too many unknowns, right? So that's why you have to use the law of cosines. Last but not least, number 14. So number 14 here we have, what do we have? We have two angles, so we have two angles and one side length. One side length. How do you spell length? Oh my goodness, I'm horrible at this. Um, THS, I am not an English teacher, right? Okay, cool. So again, if I have two angles, one side length, I think I've said this earlier. If I have one side and two angles, law of sines, so same thing here. I would do law of sines. And just to be clear, if it wasn't already for number 13, I did law of cosines. Cool. So again, I have, this is opposite of this, so this is C right here. So I have sine of 22 degrees all over 7 is equal to sine of 83, that's my other angle, all over A, or what people would like to call is BC, right? BC. Okay, and I'm solving for BC now, so I cross multiply. So BC times sine of 22 degrees. Where is that coming from? I am cross multiplying. I am doing the butterfly, whatever you want to call it, equals 7 times sine of 83 degrees. Beautiful. Now, what do I do next? Again, this is pretty straightforward. I just divide both sides by sine of 22 degrees. What I do to one side, I do to the, yep, I hope you said it, equals to this entire blah, right? This blah. Copy, paste. And now, are we done? No, you need to give me an exact answer. Well, yeah, I want you to give me a decimal approximation. Just because when you're talking to a client, if you're in engineering, you're not going to tell your client, this is the site length for your house, right? You want to give them an actual answer. So 7 times sine of 83 degrees, dividing this by sine of 22. Again, we have to be in degrees. Mode degrees, perfect. So BC is 18.55 feet, right? We're talking about feet here. Yeah, this is feet, 18.55 feet. Okay, so that was that. Let's find measurement of angle B. So again, measurement of angle B is equal to 180 degrees minus 83 minus 22 degrees, right? A triangle adds up to 180 degrees. So if two angles are approximately given to you, you can find the third angle by just subtracting everything from 180. Okay, that is important. So 180 minus 83 minus 22 is equal to 75 degrees. So this right here, what is happening? Oh my goodness, please don't die on me. Is it gonna die on me? No, 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 please don't die on me. Oh my goodness, I'm plugging this in now. Is it dead? Oh, no, it's not dead. Okay, but I think it's just frozen. Oh, okay, perfect. Okay, but I plugged it in now. What is happening? Nope. Sorry for the technical difficulties. So again, what do we get? 75 degrees. So this is equal to 75 degrees. Okay, so we're getting really close to our last part of today's lesson, which is we found BC, finding AC. So now we need to find this side right here. So again, really up to you, whatever you want to use. So you have to use this angle, right? So I have to use, let's do it over here. So I have to use sine of B, so sine of 75 all over AC is equal to, and at this point you're able to use whichever one you want. I would use the one that's given to you because it just makes a little bit more sense that you use what they give you. So sine of 22 is equal to 7, and then you solve, right? So AC is equal to, well, let's finish it off. So AC times sine of 22 is equal to 7 times sine of 75 degrees. And then last but not least, divide both sides, right? So AZ is equal to 7 times sine of 75 degrees all over sine of 22 degrees. Okay, again, you want to make sure you plug this into our handy dandy calculator, right? So 7 sine of 75, close the parentheses, dividing this by sine of 22. So I get 18.05. So AC is 18.05 feet. Okay, this is talking about feet here. Okay, so that was a lot for today. I hope that it's all kind of making sense. Again, please feel free to reach out if you have any questions about anything that I did. Go to your office hours, see your teachers, and have some fun while doing this. This is all fun stuff. I hope you all are enjoying it, and I hope you have a great rest of your day. Okay.